Let's tackle question 13 of the 2018 Edexcel A-Level Mathematics Paper 1. This question is worth 7 marks, which gives us about 8 minutes to solve. Okay, at a first glance here, there are two ways to go about this. We could either use a substitution, or we can do it by parts. This tutorial, we're going to do it by parts. So, there's a formula for integration by parts, which is derived from the product rule of differentiation. Additionally, we need to integrate terms in this form. Once again, there's a formula for this, which is again derived from differentiation. Okay, so integration by parts is all about integrating the product of two functions of x. Basically, it's where two functions of x are multiplied to each other and you cannot expand them to get singular x terms. So if we look at our function here, 2x into x plus 2 to the power of half, we cannot simply expand it and get x terms, which we can simply integrate on its own. There are two separate functions which are multiplied against each other. That's where we should use parts to integrate this. So if we look at parts over here, we have a u and a dv over dx. Those are the two functions that are getting multiplied. So we can assign them. So if we look at what we have 2x and x plus 2 to the power of half. Now, when it comes to assigning them, we could either go 2x is u and dv over dx is simply x plus 2 to the power of half. Or we could go the other way around and say, instead 2x is dv over dx and u is simply x plus 2 to the power of half. We can go down both routes. But before choosing a path, we must consider this integral over here, this part of the path formula. Now this part especially, it's another integral. Hence, if somehow this ends up as another two functions of x multiplied against each other, we'll have to solve it again via parts. And if it ends up as another two functions of x multiplied against each other, we'd have to again use parts to solve this, and it becomes nested until we can solve it. Now, if we do not assign them carefully, this could be a big time waster for us. So if we look at the main ways to assign them, we need to consider this part, this derivative, right? So du over dx is going to be the derivative of whatever we choose u to be. Now this is very useful because one main aim here is to bring out a constant so that we can focus only on v, this function of x. So if we can make one of the functions to differentiate into a constant, then we'd be able to integrate it nicely. So if we look at the two terms we have 2x and x plus 2 to the power of 1/2. Now, if we look at the flow, we're going to either integrate dv over dx, one of these, and it will become v, or we can differentiate it and it will become du dx. Now, if we look at each of these, so we're going to be focusing on du over dx, because if we want a constant, differentiating is the only way to get one, because you never get a constant from integrating a term. That's not the way it works. It's the other way around. You only get constants after differentiating. Hence, if we differentiate both of these terms, 2x, it becomes 2. So straight away, we can know, okay, this is a good candidate for use in first place. Whereas here, if we differentiate this once, we're going to use the chain rule, it will simply end up as another function of x, which wouldn't be much help. Hence, it would make sense to assign u to 2x. Now, if we go ahead and assign them, we can simply make u to be 2x and dv over dx to be x plus 2 to the power of 1/2. Hence, du over dx is going to be 2 and v is going to be the integral of this. And now that we have our u, du dx, and v and dv dx, we can simply slot them into this formula and solve for it. Now, simply slotting in the values, the integral of 2x into x plus 2 power of half equals uv, 2x into v, minus the integral of v into u's derivative. Now let's simply take out the constants and rearrange it nicely. Now let's integrate this term. And here is our integral. And since we had a definite integral with two limits, 0 and 2, let's add the limits and solve for them as well. They want us to take out a 32 over 15, which we can easily do. And there we go, we have solved it. This video was brought to you by Memseed Academy.